Hi, I'm Dr. Jonathan Hoover, and I teach in master's and doctoral program at Regent University, and I teach stats mostly. And as you can imagine, I teach a lot of SPSS. I've been using SPSS for a long time. That was what I was taught to use when I was in grad school. And so now, though, we have this thing. AI has come out. It's changing everything. And who knows? Maybe SPSS will integrate AI at some point. I don't know whether that would even work with the way that SPSS works natively, but that may happen. But for now, we have to think about the fact that there are other stats platforms, and I'm not talking about just vanilla ChatGPT, which I would not use for stats, but there are platforms specifically for doing data analysis using AI that I think are a good thing for us to think about as an alternative to SPSS. As a matter of fact, in my classes that I'm teaching, we are offering students the opportunity to use Julius.ai, one of these data analysis programs, as an alternative to SPSS. They could use it instead of SPSS if they would like to. The one thing is that SPSS is really particular about how it runs certain kinds of analysis. It doesn't run an ANOVA in a plain vanilla way like programming language like Python or R might run that ANOVA. It doesn't run Levine's test the same way. Even things like skew, there are some gentle differences in how SPSS goes about what it does. And so one of the hiccups that has been present for those who are thinking about using AI as a replacement for SPSS is in order to get the same answers, there had to be some sort of bridge. How do we get AI to give us the same sorts of answers we get with SPSS? That's what this video series is about. I did my own journey to figure out how we could get there, working with the great folks at Julius.ai who've been super, super collaborative with me as we figured this out and are continuing to be. And I think that even after this series of videos comes out, this is going to get better and better. I'll try to update it as we go along. Personally, I am migrating my own statistical analysis regimen from SPSS to Julius.ai. It's good enough that I'm moving across. Now, I will say that even before this happened, I had experience programming in Python, and so I was doing a lot of sort of advanced statistical analysis in Python, writing my own code. What's great about Julius is it's going to write code for you, so you don't have to worry about that part. And really, anybody could do this. In fact, in my opinion, there are a lot of ways in which this is a more user-friendly process. But let's talk for a minute about the pros and the cons of making this switch, or at least doing what we're doing, which is allowing students to choose between these two platforms. They could continue to use SPSS, they could use Julius, they could use a mix of the two, so there's all sorts of options. What are the pros and cons of migrating to Julius from SPSS? So first, let's talk about the pros of Julius.ai. And by the way, Julius is just one of a few different platforms that are doing this. And what I mean by this is it's using Python or R, two statistical programming languages, to do the analysis. But what the AI part is doing is it's taking your prompt, your written prompt. I want to know if there's a statistically significant difference between gender on such and such dependent variable, and then it's actually writing the programming code in Python or R, so you don't have to write the code, and then giving you nicely formatted output. So that's what Julius is doing. And really that's what's happening in SPSS, isn't it? Because SPSS is still a syntax software. So behind the scenes of what's happening in SPSS, code is being written to run the analysis. And really the graphical user interface of SPSS, what it is just programmed modules where someone has gone in and programmed a module to allow user input, where we're selecting the variables that we want tested and the options that we want in terms of what kind of output that we want. And then when it's run, it translates that into syntax. If you turn the syntax output on in SPSS, you'll see the syntax that it has created. This is basically the same thing, except that with SPSS, you're limited to how that module was written, and SPSS is always going to execute that syntax the same way every time. With AI, you're not limited to existing modules, and you can prompt it how you want to prompt it, but it's also going to write the code fresh every time. So there's just a different procedure there. Anyhow, let me get into these pros for Julius. So conversational analysis. This is where those AI platforms really do amazing work, because it allows us to write natural conversational prompts and have it translated into the task at hand, both the task and the code. There are better visualizations, and nobody is arguing this, that for a long time, Python and R and the libraries that they use have created much better visualizations than SPSS is really prepared to generate. And the other thing that's really great about the visualizations, and I'm going to skip to the fourth point here, because when I talk about refining prompts and visualizations, if I get a graph and I want it to use different colors, or I want the legend to be in a different place, or I want to overlay another graph on top of that graph, or all kinds of different things that I can do. The possibilities are really endless. I can tell the AI engine that I want the graph that it just gave me to look like this, or I want the change to be made, and it will do that for me. SPSS is obviously limited to whatever's already been programmed there. When I talk about greater analysis abilities, what I'm talking about there is that there are lots of things that SPSS really should be able to do that we would have probably liked for it to be able to do a long time ago. I'm very thankful, for instance, for the Haze plugin that allows us to do moderated and mediated linear regression in SPSS. That's a wonderful plugin. It does the steps that are needed to do moderated and mediated regression with the proper centering and all the things that need to happen in order for it to really be an accurate result. But let's face it, SPSS should have been doing that a long time ago, right? And we shouldn't have to use a plugin. And beyond all of that, because it is a plugin written by Dr. Haze, if you really want to understand the different models that plugin uses and the output that you're looking at, you need to buy Dr. Haze's book. And even at that, and I've had wonderful conversations with Dr. Haze on email. He's brilliant. Not all of my students are going to be able to understand the concepts that are in that book, as wonderful as they are, as accurate as they are. So one of the great things is with something like Julius.ai, I can do a moderated or a mediated regression. I don't have to worry about looking for that documentation on all the different ways that it could be run. AI is going to help me parse that out. And then in the response that I get, I can either read the response and make sure that it makes sense to me, or one of the great things about the AI thing is that I can ask questions about the output, and it will analyze it and give me human readable answers about my output. I think in that sense, it's a great statistics teacher as well as analysis package. But there are some cons. One of them has to do with what AI people call prompt engineering. Prompt engineering has to do with the fact that we have to give Julius some guidance about how we want it to respond in order for us to get SPSS true results. So I have to tell, before we even get started doing the analysis, I have to tell Julius some stuff to say, this is how I want this done in order to get the kind of results that I want to get. As this develops and as I work with the Julius team more, and as we see some improvements made over time, less and less prompt engineering will be necessary. But by the very nature of the beast, some will always be necessary. And here's what I mean by that. Again, there is the standard variable coding for Python and R, how it codes categorical variables. It's different out of the box than SPSS. There is the standard ANOVA process that is going to use sum of squares 1. SPSS uses sum of squares 3. There's a good reason that SPSS does that, but ANOVA but R and Python were not necessarily written for social sciences out of the box, and so there are some things that we have to tell it. Python and R are not specialized like SPSS, so we have to give it some information to tell it we want it to specialize. It will work, but we have to give it some information. The output formatting is not consistent. So in something like Julius, you should get, if the engineering is correct, you should get the right answers every time. But the way those answers are presented will not be the same from prompt to prompt. So I might get a table that's formatted a certain way the first time. Next time I run it, I'll still get the same information, but the table might be formatted a different way. So what's key about this is you have to know the concepts of the statistical analysis. We no longer could say something like, so if I'm teaching my students to do an ANOVA, and hopefully I do better than this in teaching my students, but let's say that teaching an ANOVA, I'm telling my students, you always go to the table that's called tested between subjects when you're looking for those omnibus results. You're always going to go to such and such line. Like you can, in SPSS, because you're going to get the output in the same format every time, you could almost say, look for this table, look for this line, look for this column, right? And it's not going to work that way in Julius. And I'm actually kind of liking that, because ultimately the results are going to be correct. They're going to be correctly labeled. They just are not going to be in a place where we can tell students exactly where to look every time. They're going to have to read the output, and they're going to have to know what they're reading. It's going to be nicely presented, but they need to know the basic concepts. In this way, actually, it allows us to make sure that our students really get what the tasks are that we're asking them to do. And that's the part that there is about requiring greater understanding of concepts because of that output difference there. So, pros for SPSS, and those of you who are absolutely love SPSS will be frustrated with me that I don't have 3 pages of pros, and I get it. I love SPSS. I've used it for a long time. I have nothing but good feelings in my heart toward SPSS. So, but these are the ones that to me stand out the most in the context of this conversation. First of all, it's a familiar and time-tested user interface. The one thing about SPSS that you have to give it, other than some recent issues with loading with the Mac operating system that I think they're at least working on getting past, it is not a system that has a lot of bugs. It's not a system that has a lot of known issues. Over the years, they've tuned those out pretty well. And even if you haven't used SPSS in years and you come to SPSS, chances are it's going to feel familiar. They only make small changes. When I first started using SPSS, variable types had nominal, ordinal, interval, and ratio. Now it's nominal, ordinal, and scale. The EM means box in the univariate GLM analysis has been moved. There's some little things like that. But for the most part, the one thing I got to hand it to them is they've kept their interface familiar, and it's been used for a very long time, and it has excellent documentation. You are going to get consistent output. So as long as you are using the same analysis module and you set it up correctly with your variables, you will always get the exact same output, and not just the answers. As I was saying, AI should give you the same answers. But with SPSS, you're going to get the same looking output. Like it would lay right over the top of the output. The previous time you use it would be identical, as you know. And then finally, there's no doubt that SPSS is the software that is the common software in our field. Yes, there are other stats programs that get used. I certainly have colleagues that use Stata. I have colleagues that use SAS. I have colleagues that have done what I did and gone into programming R or Python. I think R is more common than Python coding, but over the last few years, I think there's been a little bit of a migration. But anyway, all of that to say, everybody knows that SPSS is the most commonly used. And so there is a benefit to using what everybody else uses. Although I will say one of the great things about this Julius.ai is it can read and write SPSS files. Now there's a little trick to that, and I'll show it to you in the videos that I post in this playlist. Cons for SPSS: not all my students find it user-friendly. And honestly, I feel like the interface is a little outdated in the sense that it is this sort of, when Windows first came out, it was sort of a graphical user interface that was built to then run DOS code in the background. And so really it was still a DOS operating system, but Windows was just writing the code on the front end for you. And that was kind of, Windows XP was the first time that there was sort of a move away from that. And then as there have been newer iterations of Windows, we've moved farther and farther away from this idea of a graphical user interface on the front end that literally only exists as a code writer on the back end. And that's what SPSS continues to do. I think it's a little outdated. I do not like the fact that SPSS only allows one data frame per project. So you only get that one data window. Whereas in other languages like R or Python, and this would be true of the AI system that uses R or Python, you can have as many data frames as you want in your project. So if I have outliers, instead of having to delete outliers to get them out of my data frame or my data set, I can literally just create a quarantine data frame and hold those separately. And then I can integrate them later to do A/B testing. I can just leave that data frame there so I can go back and look at the information on those outliers. Now, I know somebody here who's really adept at using SPSS is listening to me say this and saying, but Jonathan, you can do that with SPSS because you can just split your data. You can create a nominal variable where you have zeros for outliers and ones for non-outliers, and then you could split your data by outliers and non-outliers. I get that. I've done it before, but let's face it, that's not the same as having the flexibility of having multiple data frames and that ability to have the software think about, okay, that's my outlier data frame. This is my normal data frame. We could temporarily merge them. We can keep them separate. Yes, at the end, there are some ways to get around this with SPSS, but the flexibility of these other programs is much bigger. And by the way, there are some things that you just can't do with SPSS that you can do with R or Python, or again, these AI platforms that write R or Python. I'll give you an example. In one study that I did, we worked with couples, married couples, and each married couple had a couple ID. This is how we kept the study anonymous, is when they did their data entry on the website, there was a couple ID assigned to them that linked those two individuals. And then we wanted to be able to analyze both at the individual level and at the couple level. Well, to do this with SPSS, to create couple pairs, was actually quite complex. Whereas with R or Python, or now with AI, it's as simple as saying, create a data frame with matched pairs by couple ID. I could literally enter that into the AI system, and it would do it all for me, and I wouldn't have to take those steps. So again, limitations, not always considered user-friendly. I've pretty much covered in my little rambling thing here the different cons about SPSS. But that doesn't mean I don't love SPSS. I really do. There are some shortcomings. And it's one of the reasons why the AI option is such a good possibility. I'm not saying it is where everything is going, but I think we should look at it, because I do think there are some benefits for students, and for, as I said, even for my own data analysis, I'm finding it very helpful. So I hope that you take the time to look at this playlist of videos where we're showing you how to do everything from descriptives to reliability testing on scales and beyond. Hopefully I'll be continually adding videos of all sorts to this playlist, and finding out whether this is right for you and for your students. And I hope that if you have any questions, you'll feel free to write in the comment thread, or write to me at JONAHOO. It looks like Jonahoo at Regent, REGENT.edu. I would love to hear your comments, concerns, problems that you're running into, because if you are running into problems, that lets me know of things that my students might experience. And I would love to help you in this process. I will let you know I am using Julius, so I'm most helpful as far as that's concerned. I have not kept up with DeepNote or some of the other platforms, so I may not be as helpful with that. So anyway, I hope to see you in the next videos as we continue to look at how to use Julius as an alternative to SPSS.